Hello. Our last tutorial we discussed computation of determinant of a matrix, and in today's class also we're gonna see how we can compute the determinant of a matrix using cofactor method. In this method, the determinant of general matrix equals to the sum of the products obtained by multiplying elements of any row or column. We multiply the elements, mark this point, we multiply the elements of any row or column by respective cofactor. So we have to find the cofactor, then we multiply by the elements, then we add up all these terms to find the determinant of that particular matrix. Yeah, we find the cofactor, we multiply by respective element, then we add up all these terms to come up with the determinant of that particular matrix. And what is this cofactor? You have to know how to find the cofactor first, then from there you can find the determinant. So a cofactor is obtained by deleting the row and column which intersect in that element. Then you designate a proper sign. So let's see. We have a matrix A, B, C, D, E, F, G, H, and I. So somebody tells you find the cofactor of A. Yeah, A. So to find the cofactor of A, we have to delete the row and the column which intersect A. So the row which intersect A is BC and DG. We delete it so that we remain in EF, H, and I. Yeah, EF, H, and I. So we multiply them. Yeah, then to find the cofactor of A, we do the diagonal operation where we say EI minus FH. Then we multiply with the proper sign. How do we find this proper sign? We know that A belongs to first row, first column. So if it belongs to first row, first column, you add the row and the column which A belongs, which is first row, first column. Yeah, first row, first column. So I for A we know is 1, and J for A is 1 also. So I plus J gives us 2. And if the sum of the row and the column is an even number, then we multiply the minor. Yeah, we've multiplied the minor by a positive 1. Whereas if it's an odd, I plus J is odd number, then we multiply the minor by negative. And from this we would have designated a proper sign of the cofactor, for the cofactor. So let's say actually, before we go to an example, this cofactor method is what laid the basis for finding the determinant of a 2 by 2 matrix. That this is a very easy method. This is a very easy way. Yeah, finding the determinant of a 2 by 2 matrix is actually easy. Whereby if you delete this and this, you'll have a D. Yeah, then D, you know that A belongs to the first column, first row. Then we say it's we multiply it by a positive 1, because so that we have D. Yeah, then for B we delete this and this so that we have C. Yeah, because B belongs to the first row, second column. We add 1 plus 2, we get 3 there. Because it's odd, we multiply by negative 1 so that we have negative C. Then to find the determinant now, to define the determinant, we multiply the cofactor by the element. So the cofactor is D, and its element, the element was A. So it's A times D. Then we add. Yeah, we add. I think there was a statement that said you sum up all these terms. Then you add. The cofactor is negative C. Then you multiply by the element which was B. So that we have A, D, positive negative is negative minus B, C. So this is what you are taught in high school, where you say that you just take AD minus BC. And this, the cofactor is what laid the basis for this particular formula. So let's focus on a 3 by 3 matrix. Yeah, 3 by 3 matrix. We go straight into example where you are asked find the cofactor. So let's begin with the how to compute cofactor. Then from there we'll compute the determinant. Yeah, just one example because I think I've elaborated. So let's say we have a matrix 3, negative 2, 4, 1, 2, 3. So you have this matrix. Then you are told to find the cofactor. Find the cofactor of A. So this matrix was A. Yeah. So find the cofactor of A. Yeah. So what you are going to do, not the cofactor of A, sorry, but find the cofactor of A11 and A23. Sorry. So A11 and A23. So you know that A11 is 3 and A23 second row, third column. A23 second row, third column. That is 3. A23 is 3 also, yeah? 3, this and this. So how do we compute the cofactor for this particular element? So we know that 3, the first 3 belongs to the first row, first column. So we delete the row and the column in which 3 belongs. The first 3 belong to this and this, so that we remain with 2, 3, 5, negative 1. Yeah? So from here we can find the cofactor. So you say 2 times negative 2 is times negative 1, sorry, is negative 2, minus 3 times 5 is 15. We have negative 17, but we've not designated the correct sign for the cofactor. This is not cofactor yet, yeah? So we know that 3 belongs to the first column, first row. So I plus j is 2. That is 1 plus 1 is 2. It's an even. So we'll multiply this minor here, this negative 17, by the sign, which is positive 1, because the I plus j is an even number. So we have the cofactor 17, negative 17. Then for the second 3, which is in the second row, third column, we delete the row, the second row, and the third column, so that we have 3, negative 2, 4, 5. Doing that, we'll have 15 minus negative 8, we have 23. But this is not the cofactor yet. Why? Because we have not designated the proper sign. We have not designated the proper sign. So the proper sign is designated how? So we say this 3 belongs to the second row, third column. So if we add the row and the column, we get 5. And 5 is an odd. Yeah? It's an odd number. Therefore, we'll multiply this minor. This is called a minor. The minor with a negative 1, because it's an odd. Yeah, we say that for odd we multiply the minor by negative 1, and for even we multiply the minor by positive 1. So it's 23 times negative 1, that we have the cofactor as negative 23. So by doing this, you get the cofactor. You can find the cofactor for all these elements here. For all these elements here. And after finding the cofactors of all these elements, you can also go to an extent of finding the determinant, which was our major focus today. Determinant of the matrix here. Determinant of matrix. Now we've known how to find the cofactor. We can now know how we can use the cofactor method to compute the determinant of a matrix using the Laplace expansion. So we just go straight to an example. Also in this, because the cofactor thing is what's major here. So after knowing the cofactor, now you can compute the the determinant easily. So let's go into another space where we say find the determinant. So let's write the equation. Two, 3, negative 4, 0, negative 4, 2, 1, negative 1, 5. It should be 5. So we can compute the determinant of this particular matrix using the cofactor of the Laplace expansion. So we can just say we use the elements of the first row, we compute their cofactors, then we use it to find the determinant. So let's say 2. Note 2 can be designated as A1, 1, belongs to first row, first column. We delete the row and the column which 2 belongs, so that we remain with negative 4, 2, negative 1, 5. So computing the cofactor of this, so the minor of this, we are going to get it as a negative 20 minus 2. Negative 20 minus 2, and we get negative 18. So that is the minor. Then because 2 belongs to the first row, first column, we multiply it by positive 1. Negative 18 times positive 1, because 1, the row plus the columns give us an even number. So we'll have our cofactor for 2 was negative 18. So that's the cofactor. Then cofactor for 3 belongs to row 1, column 2. So deleting the elements of row 1 and column 2, we remain with 0, 2. Remain with 0, 2, 1, 5. We delete first row, second column, we remain with 0, 2, 1, 5. Then finding the minor, we say 0 times 5 is 0, minus 2, that is negative 2. And because 3 belongs to the first column, second row, if you add it, you get 3, which is an odd number. Therefore, we multiply it by not positive actually, but negative 1. Because it's odd, we multiply by a negative 1, so that we have 2 as the cofactor. And then we compute for negative 4, A1, 3. It belongs to the first row, third column. If we delete the elements of first row, third column, we remain with first row, third column, we remain with 0, negative 4, 1, negative 1. Computing the minor, we remain with 0, minus 4, that is 4. Then, because this belongs to first row, third column, if we add the row and the column, we get 4, which is even. Therefore, the minor we multiply it by a positive 1, so that the cofactor be 4. So, we've gotten the cofactors here, but we've not. What was our focus? To get the determinant of this particular matrix B. To get the determinant, we multiply the cofactors by the elements, by their respective elements. So, the first cofactor was negative 18, and its element, the element of that cofactor is 2. So we take 2, we multiply by negative 18, so that we have negative 36. The second element was 3 and its cofactor is 2. We multiply 3 times 2, we have 6. Then the third was negative 4 and its cofactor is 4. If we multiply, we have negative 16. And from there, we add up all these terms. We add up all these terms to get the determinant, where we'll have negative 36 plus 6 minus 16, so that we remain with negative 46. And this is therefore the determinant. Therefore, the determinant of B is equals to negative 46. And you can use any other row. Yeah, it's not necessarily that you use the first row. For me, I've used the first row to demonstrate how you can compute the cofactor, and from there you can do the determinant. Yeah, so you can use any other row. You can use the second row or the third row. You'll get the same answer for the determinant. And I hope this can help you to find the determinant of a matrix easily. Yeah, though it's quite long compared to what we did in our first tutorial, but this cofactor method it lays the basis for the finding determinant of a 2 by 2 matrix. So I saw it good if I can share it with you, so that you at least you can also see how the formula of finding the determinant of a 2 by 2 matrix came into. Yeah, so I leave it from there. I hope we're gonna meet in the next tutorial. Thank you.